So Schrodinger's cat is this experiment where there's a cat in a box, theoretical experiment. Nobody's killing any cats. And there's some poison in there, and there's some radioactive material that has a 50% chance of setting off the poison and a 50% chance that it won't, let's say after an hour or so. And so after an hour, the chances that the cat is dead or alive is 50%, right? Because it's a 50% chance. But what the observer effect and what quantum mechanics is telling us is that both of those possibilities exist. The cat is both alive and dead until somebody looks at that box, right? The observer in this case. And so until then, the cat is in the state of superposition, okay? And this is what makes quantum mechanics so weird, right? This is why, Richard Feynman, Nobel Prize winner, said nobody understands
right.
quantum mechanics. And Niels Bohr said, if you're not shocked by this, then you haven't understood it, okay? Because to us, the cat has to be alive or it has to be dead.
And we don't know until we see.
We don't know until we see, but it's only one. And common sense tells us it's one of those, right?
Right.
But quantum mechanics, through the double slit experiment and the observer effect, says both of those possibilities exist in the present until the time when someone looks and someone measures that result. So then we say the superposition, which is two states, comes down to one state. So the cat is both alive and dead. And then when somebody measures it, it's either alive or dead, and we're in one of those states, right? Okay.
Right. So, I kind of understand what you're saying, but isn't it really just that we don't know until we open the box? And it's not that the cat is both alive and dead. The cat is either alive or dead. We just haven't figured it out yet until we open the box.
That's what it would seem like, right?
Right.
That would be like common
Logical.
sense point of view, right? But
right.
what all the physicists have been telling us now for almost 100 years, right? Going back to the 1920s when quantum mechanics first started to get formalized, is that that's not actually the case. That what happens is you have this probability wave, and that there are different probabilities of the cat being alive or dead. Now, of course, they weren't talking about cats. That
right.
was
The cat is maybe too simplistic. It's like a placeholder. You know what I'm saying? Like
it's a way for somebody to think about this at a high level. So
right.
Schrodinger, who was one of the founders of quantum mechanics, through his wave equation, he basically came up with this because he thought the whole idea was ridiculous. He's like, look, you can't have a cat that's both alive and dead, right?
Right.
So this is a ridiculous experiment, except it's become the way in which we explain this weird effect about quantum mechanics. Now,
and the weird effect in quantum mechanics is things can be both moving and still at the same time, which is superposition, right?
Right, or they can be in two different